I'll now speak about regulating heart rate. The sinoatrial node controls the nervous system, and this is what helps regulate the heart rate. And this is done by the sympathetic and the parasympathetic nerve. To start off with, I'll speak about the sympathetic nerve, which increases the heart rate when the body is under physical or mental stress. Physical stress is like exercise, and mental stress is anxiety. The release of a chemical called norepinephrine causes the increased heart rate, and this is very good for physical sports such as rugby or weightlifting. This is because the body needs to be prepared for the large exertion and the muscle contraction that is going to happen for the sport. So having an increased heart rate makes the person physically and mentally ready for the exercise, as they have more oxygen at muscles. For sports that require more precision, an increased heart rate won't be very good because they won't have a steady hand, or for high pressure situations such as a penalty, the person taking the penalty will need to be calm and cool so that they can score. Going on to the parasympathetic nerve, this is what slows down the heart rate, and this usually occurs after something that has caused stress has now passed. So that could be there was a threat to score a goal, so the keeper may have had an increase in heart rate, but the shot went wide, so now they're calming down again. The release of acetylcholine causes the decreased heart rate, and this is very good for precision sports such as archery, as they need to have a steady hand so that they can score higher points and win the game. A low heart rate will keep the body calm so they'll have a steadier hand and can make better shots and hit higher targets each time. Like I said previously, for large exertions in weightlifting, having a low heart rate wouldn't be very good because the muscles need to have a lot of energy built up so that they can do that large exertion and lift the weight. So a low heart rate wouldn't be very good for that. Now going on to the blood vessels. There's 5 types of blood vessels within the body, and they are the arteries, the arterioles, the capillaries, the veins and the venules, and they can all be seen in this diagram down there. I'll start off by talking about the arteries, and they're used to pump the oxygenated blood around to the rest of the body, which is very good during sport and activity as the body needs high amounts of oxygen. The lumen of the artery is very narrow and strong, as the pressure of the blood going through the arteries will be quite high. This means that the lumen needs to be strong so it can hold blood and handle the high pressures. One artery, however, can carry deoxygenated blood, and that is the pulmonary artery, which carries the deoxygenated blood from the heart to the lungs in order to pick up oxygen. Now going on to the arterioles, which are found there. They connect the arteries to the capillaries and have a smooth muscle surface to control the blood flow in a much easier way. The flow of blood needs to be slow, as it means that more oxygen can be delivered in a more efficient way, as well as taking carbon dioxide away better. This is because the blood flow through the working muscles, if it's slow, it can easily drop off oxygen and pick up carbon dioxide because it has more time to do so when it passes by. This benefits performance as oxygen can be delivered and waste products can be taken away, so these factors working together make fatigue less likely. Now going on to the capillaries, which are this middle bit here, and these are the thinnest blood vessel within the body, and that's because they're only made of a single layer of endothelial cells. Because of this thin surface, the diffusion of oxygen can happen much easier and quicker because the blood is close to the cells that need the oxygen, so the diffusion of the gases will happen easier as there's less cells to travel through beforehand. The capillaries also have a very large surface area, which means that they can diffuse a lot of gases at one time. The whole muscle can also get oxygen due to the capillaries being over the whole muscle. This is good because the working muscles will then get more oxygen, so the performance will be better. Veins have a similar structure to arteries, but they are much thinner and they have less elastic and less muscle. This is because the pressure of the blood travelling back toward the heart, which is the purpose of the veins, to take deoxygenated blood back toward the heart, is going at a much slower speed and lower pressure. This means that the veins don't need to be as strong as the blood is flowing slower. The blood flows slower and has less pressure because the lumen of the veins are very wide, which means that the blood has a larger space to travel through, which will reduce the pressure. The valves in the veins also prevent backflow of deoxygenated blood, because this then keeps all the blood separate and then keeps it going in the direction it needs to get oxygen again. Similar to the arteries, one vein can carry oxygenated blood, which is the pulmonary vein, and this carries blood to the heart from the lungs. Now going on to the venules, which are found there, and these are similar to the arterioles, but they connect veins to capillaries in order to drain the blood from the capillary into the veins. This is so that the blood can travel back to the heart and the lungs to become oxygenated before being delivered to the working muscles once again. Now going on to the layers of the blood vessels. There are 3 layers of blood vessels, and they are the tunica externa, the tunica media, and the tunica intima. The tunica externa is the very outer layer, which can be shown here, and it is made of collagen and elastin fibres. It also acts as a shock absorber for the blood vessels. Due to the things it is made of, the tunica externa helps to keep the shape of the vessel as well. The tunica media is the middle layer, which is found here, and this is made of mainly smooth muscle with elastic layers and collagen. This is the part of the vessel that vasoconstricts and vasodilates, as it is stretchy and it can be moved easily. It is also made of a smooth muscle to allow the blood to flow through easier, and this is done to reduce blood pressure and friction, just so everything can go more smoothly. Finally, the tunica intima is the very inner layer of the blood vessel and is found there. It is made of smooth epithelial cells called endothelium. These cells are smooth to help reduce friction between the moving blood and the surface of the vessel, and it does this by creating a smooth slippery surface so that the blood can flow through much easier. Now going on to the components of blood, and there are 5 components, which are erythrocytes, leukocytes, hemoglobin, plasma and thrombocytes. Starting with erythrocytes, and these are better known as red blood cells, and they're used to deliver oxygen from the muscles to the muscles from the lungs, and also due to their concave shape, which can be seen in the image here, they carry the oxygen molecules. They can carry up to 4 molecules at one time and deposit them to the working muscles, as well as take in oxygens to the muscles. They can also take carbon dioxide away from the muscles toward the lungs. Going on to leukocytes now, and these are white blood cells that are used to defend the body against foreign bodies such as viruses, bacteria and parasites. White blood cells make up 1% of blood, which can be seen in this image here, which shows the percentage of each component within the blood. Going on to hemoglobin, which is the protein that makes red blood cells the colour that they are. And they also have a high affinity for oxygen, which helps to increase the amount of blood getting to the muscles during exercise. Due to the high affinity, they make oxygen bind to the red blood cells. Also, the red blood cells contain a lot of hemoglobin, which means that they can transport a lot of oxygen due to that high affinity. Going on to plasma, it's simply the liquid and substance of the blood, which carries the solids such as cells around the body so that it can get to the important areas that it needs to get to. The plasma is a sticky liquid that is similar to the colour of straw. And the thrombocytes are also known as platelets, and they help to clot the blood at an injured site of the body. Once the injured site has been blocked and clotted, then the platelets will turn hard, which is what the scab is made of. When exposed to air, the platelets will then become sticky, which helps to block up the injured site as they can join together and stay very compact. Their spiky shape also helps them stick together, which can once again be seen in the image here. Because of the spikes and the stickiness when they touch the air, they just stick together and stay very much compact so that the injured site is completely sealed up and no more blood will be lost. The last thing I'm going to talk about is the functions of the blood, and there are three main functions, which are oxygen transport, clotting, and fighting infection. Oxygen transport occurs because the oxygen binds to the hemoglobin within the red blood cells, and then it can get moved around the body in the circulatory system. The blood travels all over the body in this system, so the oxygen is easily transported and diffused to all the working muscles that require the oxygen, especially during exercise. The blood also transports nutrients and hormones. In this substance here, the plasma, that is how the oxygen and nutrients move around the body. On to clotting. Clotting is very important because it prevents the loss of too much blood. This is done through the use of platelets and fibrin, which cover up and fill an injured site to stop the bleeding. When exposed to the air, platelets will become sticky, so they become very compact and stay together in order to plug up the injured site. The platelets can be seen here and here, and they show their spiky and sticky substance, so just to show how much they stick together when blocking up the injured site. Finally, the final function of blood is to fight infection, and this is done through the use of white blood cells, as they contain antibodies. These antibodies are used to defend the body against viruses and bacteria, which then prevents infections, as the foreign bodies have been destroyed. As soon as viruses or bacteria enter the bloodstream, they'll be attacked by the antibodies within the white blood cells. The antibodies and the white blood cells can be seen in these circular things here. That is the end of my presentation.